Hello viewers, welcome to Chemphilic. So let's start 32nd episode of Teaching Chemistry through Riddle. And today's riddle is framed on few topics of chemical kinetics. So let me discuss first few topics of chemical kinetics in brief, followed by the riddle will appear. We'll solve the riddle immediately, and based on the concept, some problems on chemical kinetics will be solved. So let's start. Now chemical kinetics deals with the rate or speed of a reaction. Then what is meant by rate or speed of a reaction? See, we know that when the reaction occurs, reactant converted to product. So, what happens? The concentration of the reactant decreases with time and the product is forming. So, concentration of the product increases with time. So, rate of the reaction means this change of concentration of the reactant or the product with time during the course of reaction. Now the second question will appear, then why we will study the rate of the reaction? Okay, we have seen some reactions are very fast, like ionic reaction. You add silver nitrate and sodium chloride, immediately silver chloride precipitate will form. Then some reactions are very slow, say 2 moles of hydrogen, 1 mole of oxygen. Thermodynamically, it is a feasible reaction to give water. But you mix 2 moles hydrogen, 1 mole oxygen, keep it in the normal condition. After 1 month also, you will not get a drop of water. So these are very slow. In between, some reactions are there which are not very fast and very slow. Okay, then why you study the rate of the reaction? Yes. There is an importance in studying the rate of the reaction. We'll see it soon, because from the rate of the reaction, we can develop the possible mechanism or pathway of the reaction. Now, coming to this rate, already I told you, change of concentration of the reactant and product per unit time. So this is one hypothetical reaction, A plus B giving the product P. Now change of concentration of A is reactant. Reactant concentration decreases with time, so negative. So ddt of molar concentration of A, that is the rate. Or you can express rate in terms of any reactant or any product. So that will be equal to, again, if you express the rate in terms of B, that is minus ddt of molar concentration of B, or you can express in terms of change in the concentration of the product P. And this reaction, as I have written, small dT of molar concentration of A, this indicates the instantaneous reaction rate. What does it mean? It means that it gives the reaction rate at a particular point. Say here the time is 12 hours. At this particular point, what is the rate? Only for that particular point. And how to calculate the rate? At this point, you have to draw a tangent. Then slope of the tangent will give you the rate at that point. So that is instantaneous rate. Now another one is average rate. Average rate means they have studied the reaction, say for 10 minutes. Then 10 minutes, what is the change of the concentration of the reactant or product? So change in the concentration of reactant, it is capital delta molar concentration of A by capital delta T divided by, say, 10 minutes. Okay, that is the average rate. Now another one is initial rate. Initial rate means that instantaneous rate at the beginning of the reaction, that is initial rate. Now what will be the unit of rate? Rate, we have observed that change of molar concentration of the reactant or product. Concentration we express in terms of moles per liter. So it will be moles per liter divided by time. So moles per liter and then time inverse, so divided by time. Okay, so this is the unit of rate. Now, coming to rate law. See, rate of the reaction depends on the concentration of the reactant, because rate is nothing but change of concentration of reactant or product. So, there is the equation which equate or which relate the rate with the concentration of the reactant. That is known as the rate law. Okay. So this is the hypothetical reaction. A plus B plus C gives rise to the product B. Then rate is equal to, rate means, if you consider instantaneous rate, anything minus ddt of molar concentration of A you can write, or minus ddt of molar concentration of B you can write, anything. So rate will be is equal to, because rate is proportional to the concentration of reactant. So to remove the proportionality, you have to get some constant. So rate will be is equal to some constant into concentration of the reactant to the power, some power is there in each concentration. This I will discuss very soon. Okay. So rate law is nothing but the equation that relates rate of the reaction with the concentration of the reactant. Now coming to rate constant. So see this hypothetical reaction, A plus B gives product B. So this is the rate. Alpha and beta, I'll tell about these things. These are experimentally determined quantity. Okay. Now look at here, when this molar concentration of A will be equal to 1 and molar concentration of B will be equal to 1, then all this part will become 1. So rate will be equal to K. That means when A and B is equal to 1 molar, then rate is equal to K. Now how can you define? Rate constant or specific rate constant is the rate of the reaction when the molar concentration of the reactants are unity. Now coming to the molecularity. Molecularity means number of reactant molecules involved in the simple, that means one step, or elementary reaction, or more precisely number of molecules of the reactant collide or hit each other for a particular elementary reaction to give the product. Later we'll come to know in collision theory how the reaction occurs by the collision among the molecule. So for these molecules, molecularity is 2. That is 2 HI molecule collides in a simple step or elementary reaction. Now coming to order of the reaction. See this hypothetical reaction, A plus B plus C gives the product P. Now rate, already I told you, you can write is equal to K into molar concentration of A to the power something, it is alpha, B to the power beta, C to the power gamma. Now these powers, if you add these powers, alpha plus beta plus gamma, then that will give you the overall order of the reaction. And alpha is known as the order of the reaction with respect to A. Beta is order of the reaction with respect to B. Gamma is the order of the reaction with respect to C. And overall order is alpha plus beta plus gamma. So how can I define order? It is the sum of the powers of the concentration of the reactants in the rate equation. This equation, not in the stoichiometric equation or not this stoichiometric coefficient. This alpha, beta, gamma, these are purely experimentally determined quantity. And this order of the reaction, overall reaction or order with respect to certain reactant that may have values positive, negative, 0 or fraction. Okay? Now you see, as I told you, this order does not mean this stoichiometric coefficient. Let's see. See, very often you will get such type of question. Write the differential rate equation of this reaction. So this is decomposition of hydrogen peroxide to water and oxygen. Now here rate will be is equal to rate constant molar concentration of hydrogen peroxide to the power 1. But here stoichiometric coefficient is 2. So sometimes this power may be equal to the stoichiometric coefficient or may not be. There is no hard and fast rule that this powers will be equal to stoichiometric coefficient. No. These are experimentally determined quantity. Let's see another example. Say potassium persulfate and 2 moles of potassium iodide. Here the product is iodine is evolved and potassium sulfate is formed. Now rate will be equal to K into molar concentration of persulfate to the power 1. Here stoichiometric coefficient also 1. But molar concentration of Ki to the power 1. Here stoichiometric coefficient is 2. Okay. So it may be equal, may not be equal. So here overall order of the reaction is 1. Here overall order of the reaction is 1 plus 1, 2. Now for a multi-step reaction, the order, what is the order? That is the sum of the powers of the concentration of the reactants in the slowest or rate determining step. Okay. Now, if any reaction is a multi-step reaction, overall rate depends on the slowest step. This you can easily imagine from our daily life incidents. Say for example, one girl is preparing the dough of chapati. Okay, another girl is making the round shaped chapati and another girl is frying the chapati. Now, just imagine the first girl who is preparing the dough of chapati, she can make the dough for 10 chapatis per hour. Just imagine. And the second girl who is making the round shaped chapati, who is preparing the round shaped one, she can make per hour this round shaped chapati 20 chapati per hour. Okay. And the last girl who is frying the chapati, she can fry say 25 chapatis per hour. Okay. So first girl is making the dough for 10 chapatis per hour. Second girl making the round shaped chapati 20 per hour. Third girl is frying 25 per hour. Though the second and third girl are first, but until and unless you get the dough for this chapati, you cannot prepare the full chapati. So, overall chapati preparation rate depends on the slowest step. So, per hour, more than 10 chapatis will not be formed. Like that. If the reaction is multi-step reaction, then rate of the reaction depends on the slowest step. That is called rate determining step. Achha. Now you see, as I told you, from chemical kinetics, we can get the idea about the possible mechanism of the reaction. So this reaction, this is iodination of acetone. Okay, the product is this one. And iodide and H plus, Hi is removed. Okay, iodinated acetone, this one. Now, here you see this is the reaction, but the first step, reaction is consisting of these two steps. First step, this keto form of the acetone converted to enol form. That is the first step. And the second step, enol form reacts with iodine and gives the product. But here, the first step is the slowest step. That means rate of the reaction depends only on the first step. Though there are two reactants for this reaction, without two reactants, reaction will not proceed. But rate depends on the concentration of acetone because this is the rate determining step where keto form of acetone is converted to enol form. So you can have the idea about the mechanism. So this reaction proceeds to the formation of enol form. Okay. So rate of this reaction will be rate constant and acetone to the power 1. Okay. 1 is the order with respect to acetone. Now, integrated rate equation. Now, you have seen instantaneous rate, average rate, but say instantaneous rate, that is rate at a particular point. Now, if you sum of these things, that means say after a certain period, how much reactant is left over, how much product will be formed. If you want to know these things, you have to integrate that differential rate equation, and then we can derive some integrated rate law which is fixed for some first order reaction. That means for first order reaction some integrated rate law, for second order reaction some integrated rate law, like that. Now you see, this is first order reaction. First order reaction is sum of the powers of the concentration of the reactant in the rate equation is 1. Generally, first order reaction means only one reactant will be there. If it is an elementary reaction, one reactant involved. So, this rate law will be rate is equal to K, A to the power, that is molar concentration of A to the power 1. 1 is the order with respect to A, and this K is the rate constant. Now, this is the differential rate equation, ddt of Ak to the power A, Ka to the power 1. Then, now if you integrate this equation, you will get this integrated rate law, which is ln molar concentration A0. A0 means initial concentration of the reactant divided by molar concentration of A. A means the reactant left over after time t, and K is the rate constant, T is the time. This A0 sometimes we express in terms of small a, and this A, molar concentration of A, sometimes we express in terms of A minus X. I'll show you. X will be the concentration of the product formed at time t. Now, this is ln. If you want to convert it to log, that is base 10, you have to multiply by 2.303. Then this is the equation. Then finally, K will be is equal to, that is rate constant for in first order reaction from this integrated rate law. K will be is equal to 2.303 by T log of molar concentration of A, that is initial concentration of A, divided by concentration of A at time T. Now, what will be the unit of K for first order reaction? See, look at here in this case. Here is molar concentration, here molar concentration. It will get cancelled. There will be no unit. So you have to give only the unit for T. So T is at the denominator. So it will be time inverse. Now these are the some examples of first order reaction, that is decomposition of hydrogen peroxide, decomposition of nitrogen pentoxide, then conversion of cyclopropane to propene. All these are the example of first order reaction. Now coming to the half-life period of first order reaction. So this is the A, that is rate constant from the integrated rate equation of first order reaction. Now half-life period means time required for half of the reaction to get over, or half of the reactants converted to product. That means when T is equal to T half, then leftover reactant will be initial concentration of reactant divided by 2. Half converted to product, no? Left will be divided by 2. Now if we put it in this equation, then finally it is coming 2.303 by T half into log 2. And then if you put the value of log 2, then T half is coming as 0.6932 by K. K is the rate constant. So, half-life period of first order reaction does not depend on the initial concentration of the reactant. So, if you take more of the initial concentration, there will be no change in the half-life period. If you take the less initial concentration, half-life period of the first order reaction will be same. It is independent of initial concentration. Now coming to second order reaction. Second order reaction, say it is of two types. Twice A gives the product or A plus B gives the product. Okay, A and B concentration may be different or same, but we are taking that A concentration, B concentration are same. That means either one reactant, twice of one reactant gives the product, or A plus B gives the product. If the concentrations are same, then it is also equivalent to twice A gives rise to the product. So what will be the differential rate equation? Minus ddt of molar concentration of A will be is equal to rate constant concentration of A to the power square, because it is second order. Then if you integrate the equation, finally you will get the K value, rate constant, will be is equal to X, that means the concentration of the product form at time t, divided by A0, that means initial concentration of the reactant, into time at time t, into the leftover reactant at time t. So this can be also written as X divided by A into T, small a into T into A minus X. Okay, so A0 initial concentration of reactant, A is the concentration of the reactant at time t, X is the concentration of the product at time t. Now what will be the unit of K? Okay, now this is moles per liter. Here this is moles per liter, this is moles per liter concentration. So 1 moles per liter getting cancelled. So what is left over? 1 moles per liter, that is in the denominator. That means mole inverse liter, and this T is also in the denominator, so time inverse. Now from this equation we can also write in this way: 1 by A, that is leftover concentration of A at time t, or 1 by A minus X is equal to 1 by initial concentration of A plus KT. Now here is some examples of second order reaction, that is your decomposition of nitrogen dioxide to nitrogen and oxygen, hydrogen iodide to hydrogen and iodine, etc. Okay. Now half-life period of second order reaction. Now from this equation, just now we have derived this equation. Half-life period means T is equal to T half. Then leftover concentration, half of the reactant converted to product. Leftover concentration will be A0 by 2. If you plot in this equation, half-life is coming as 1 by rate constant K into molar concentration of A initial. That means initial concentration of reactant. That means you see half-life is inversely proportional to the initial concentration. So half-life period is inversely proportional to the initial concentration of the reactant for second order reaction. Now coming to the integrated rate law for zero order reaction. Zero order reaction means rate is independent of the concentration of the reactant. So this is the hypothetical equation. A gives the product P. Now minus ddt of A will be equal to K concentration of A at time t to the power 0. So anything to the power 0 is equal to 1. Okay. So here it is 1. Then if you integrate this equation, finally you will get this one. K will be equal to A0 minus A. A0 minus A is X. That means difference of the concentration of reactant, that is nothing but equal to product, because reactant is converted to product, so X by T. And as usual, A0 is the initial concentration of A is the concentration of A at time t, and A0 minus A, this is the X, that is the concentration of product form at time t. Now from this equation, what will be the unit? This is moles per liter. So moles per liter and then denominator times. So moles liter inverse time inverse. Now these are some examples. Hydrogen and chlorine. It is giving you 2 hydrogen chloride gas. But from the mixture, reaction mixture, time to time you have to remove this product to make it zero order. Then nitrous oxide decomposition, nitrogen to oxygen. These are example of zero order reaction. Now half-life period of zero order reaction, as usual, A, we know these things. In place of A, you have to put A0 by 2. Then finally T half is coming as is equal to A0 divided by 2K. 2K is constant. That means half-life period of zero order reaction is directly proportional to the concentration of the reactant. Now, graphical representation. See, this is zero order reaction. We know X is equal to KT. That is the equation. So, here if you plot concentration of product versus time, it is Y is equal to mx. That means straight line passing through origin. Slope will be equal to K. Now, this is first order reaction. Log A. A means A0. That is initial concentration. A minus X. That means concentration of the reactant at time T is equal to KT by 2.303. So, accordingly, if you plot, that means if you plot this one log A by A minus X or A0 by A versus time, it will be a straight line passing through origin. And what will be your slope? Slope will be K divided by 2.303, from which you can calculate K. Now, second order reaction is this one. Already you have seen the equation. So, where K is equal to X divided by A into A minus X into T. So, if you take X divided by A into A minus X is equal to KT, then if you plot this X divided by A into A minus X versus T, it will be straight line passing through origin. Slope will be equal to K. Now, for here, see, this is zero order reaction where X is equal to KT I know. Now, if you rearrange this reaction a little bit, that means first you have taken negative sign and then you have added A. So, it will become A minus X is equal to minus KT. Just imagine, here you have taken minus and minus. Minus X is equal to minus KT. Then you have added A to both the sides. Then equation will become like that. So, if you plot A minus X versus T, then it will be a straight line with intercept, because here this is the intercept on y-axis, okay, and the slope will be is equal to this K, okay, minus K, because this K is slope is negative, no, so the line is coming like this. Instead of going like this, line is coming like this. Now, this is first order reaction. So, first order reaction, if you plot log of A minus X versus T time, then this is Y is equal to M. M means K. K by 2.303. X means T. So, Y is equal to Mx plus C. Then also you will get a straight line with intercept on y-axis and slope will be equal to K by 2.303. Similarly, here is another form of the second order equation if you plot, that is 1 by A is equal to 1 by A plus X plus KT. Then also it will be Y is equal to M. M means K into T. So, straight line with intercept on y-axis. Now coming to this riddle number 32. I am related to speed of a chemical reaction. I am flexible. Based on situation, I change my value. My value ranged from negative to positive integer, including 0 and fraction. For a multi-step reaction, people determine my value from a particular step. You can evaluate my value experimentally by measuring the half-life period of the reaction. So, I hope everybody got the answer. So, the question is, what is referred by I in the riddle? And obviously, the answer is order of the reaction. Here it is overall order of the reaction. Now, another question is, how order of a reaction can be evaluated from the half-life period of the reaction? Let's see. We have observed that for zero order reaction, T half, that is the half-life period, is directly proportional to A. So, can we write down this equation like this? Proportional to 1 by 0. 0 means the orders. 0 minus 1. So, A to the power minus 1. If it goes up, it will become A. So, T half for zero order reaction proportional to 1 by A to the power 0 is the order, that is N. N minus 1. Similarly, T half for first order reaction is constant. This also I can write in this form, proportional to 1 by A to the power N minus 1. N is here 1, first order, minus 1, 0. So, proportional to 1 by a to the power n minus 1. That means here 1 minus 1, that is 0. 0 means it will be constant. T half will be constant. That means for first order also you can write T half proportional to 1 by a to the power n. Similarly, second order, what we have observed that half-life period inversely proportional to the concentration of the reactant. So this also you can write like this. T half proportional to 1 by a to the power n minus 1. N is 2. 2 minus 1. Okay. 2 minus 1 means 1. That means 1 by a. That is proportional, inversely proportional to a. That means half-life period can be written as or proportional to 1 by a to the power n minus 1, where n is the order. Now, by measuring the half-life period, you can determine the order of the reaction. So, what you have to do? First, you have to determine the half-life period of two different initial concentration of the reactant. Say, for one initial concentration of the reactant, I am denoting by T1 half. This is the half-life period. This will be equal to rate constant 1 by A1. A1 is the concentration that time to the power n minus 1. For another concentration A2, so T half 2 I can write it as K into 1 by A2 to the power n minus 1. Okay. Now you have to take the log for both the equation and then you have to subtract. Then what you are getting? Log T1 half is equal to log K and minus 1 by a to the a1 to the power n minus 1. No, if it goes up, it will become minus n minus 1 because it is as a power. Minus n minus 1 log a1. Similarly, T half 2 is equal to log K minus n minus 1 log a2. If you subtract it, what you are getting? Log T1 half. That means that is for the initial concentration A1 minus log T2 half is equal to n minus 1 log A2 minus log A1. So, from that equation, n minus 1 will be this earlier equation you see. From this, n minus 1 will be this divided by this. So, log T1 half minus log T2 half divided by log A2 minus log A1. So, in general, what I can write? Log T half. From here also you can calculate. Okay. Two different initial concentration of the reactant. You have determined half-life period. So, you know the half-life period for the concentration A1 and concentration A2. Put these values. N minus 1 is equal to these things. You can calculate N. Otherwise, if you write this equation in the general form, that is log T half is equal to log K minus n minus 1 log A. Okay, that means here. From here you see, in general form of the equation, you can write down this equation in the general form. That is log T half is equal to n minus 1 log A. That is concentration of the reactant. Then this equation becomes y is equal to mx. M is n minus 1. X is log A. Okay, mx plus c and the slope is negative. So you will get a straight line with intercept on y-axis and the slope will be is equal to n minus 1. From the slope n minus 1, from there you can calculate the order. Now coming to some problem based on these topics of chemical kinetics. Half-life period of a chemical reaction at a particular concentration is 50 minutes. When the concentration is double, half-life becomes 100 minutes. Find the order of the reaction. So from this statement itself, it is clear that it is zero order reaction because for zero order reaction, half-life is directly proportional to the concentration. For a particular concentration is 50. When it is double, then 100. But you can solve this problem. T half proportional to 1 by just now I have shown a to the power n minus 1. Okay. So T half 1 first concentration divided by T half 2 is equal to A2 by A1 to the power n minus 1. Put this value. Finally, you can calculate n is equal to 0. Problem 2. Second problem. The following data is given for the decomposition of phosphine. Find the order of the reaction. So initial pressure is 707, then half-life is 84. When initial pressure 500, half-life is 83.8. When initial pressure is 79, half-life is 84. Initial pressure here it is representing the concentration for gas. 37.5, here it is 83.5. So, you observe here, this concentration of the reactant is changing, but half-life period almost constant. So, half-life period is independent of initial concentration. So, it is first order reaction. Third problem. In a second order reaction, half-life was found to be 30 minutes. When the initial concentration was 0.1 molar, find the rate constant. First second by K into is 0, then you put the value, you will get the answer. Now, problem number 4. Rate of a homogeneous gaseous reaction 2NO, that is nitric oxide gas plus chlorine gas, 2NOCl gas is double when the chlorine concentration is double but increases by a factor 8 when the concentration of both the reactants are double. Determine the overall order of the reaction and the order with respect to nitric oxide and chlorine. When chlorine concentration is double, keeping NO constant, rate becomes double. So order with respect to chlorine is it is first order. When both the concentration is double, rate is increased by 8 times. We have seen it is double. We have seen for double concentration of chlorine, rate is double. So it is obvious that the double concentration of NO, nitric oxide, rate increased by 4 times. So that overall increase of rate is 8 times. So order with respect to NO is 2. So the rate equation will be K NO to the power square and chlorine, and overall order is 2 plus 1, 3. So this is the end of this video. Thank you.